Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 9 to the power of x minus 6 to the power of x is equal to 4 to the power of x. Now what I'm first going to do is I'm going to divide both sides by 4 to the power of x. So now I have 9 to the power of x minus 6 to the power of x over 4 to the power of x is equal to 4 to the power of x over 4 to the power of x. So then these two cancel out. So now I have 9 to the power of x minus 6 to the power of x over 4 to the power of x is equal to 1. Now, if I have something in the form a minus b over c, this can be written as a over c minus b over c. So 9 to the power of x minus 6 to the power of x over 4 to the power of x, that can be written as 9 to the power of x over 4 to the power of x minus 6 to the power of x over 4 to the power of x. This is equal to 1. Now, if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So 9 to the power of x over 4 to the power of x, that's going to equal 9 over 4 to the power of x. And 6 over x over 4 to the power of x, that's going to equal 6 over 4 to the power of x. Now 6 over 4, the greatest common factor of these two is 3. So 3 times 2 is 6. Or sorry, not 3. The greatest common factor is 2. 2 times 3 is 6, and 2 times 2 is 4. So 6 over 4 simplifies to 3 over 2. And we still have 9 over 4 to the power of x. Now for 9 over 4, 9 is equal to 3 squared, and 4 is equal to 2 squared. So I have 3 squared over 2 squared to the power of x minus 3 over 2 to the power of x is equal to 1. Now, remember, if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So 3 squared over 2 squared, that is going to equal 3 over 2 squared, and we have this to the power of x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. And these two are interchangeable, meaning this is also equal to a to the power of n times m. So if all of this is true, then this must mean that a to the power of m to the power of n is equal to a to the power of n to the power of m. So right here we have 3 over 2 to the power of 2 to the power of x, and that is going to be equal to 3 over 2 to the power of x to the power of 2. Then we still have minus 3 over 2 to the power of x is equal to 1. Now I'm going to let 3 over 2 to the power of x equal the variable u. So now I have u squared minus u is equal to 1. And now I can subtract 1 on both sides, so I get u squared minus u is equal to, u squared minus u minus 1 is equal to 0. So now I have a quadratic equation, and I can go ahead and plug this into the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac divided by 2a. So in this case, a is equal to 1, b is equal to negative 1, and c is equal to negative 1. So I have, if I plug these values in, negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 1. All of this divided by 2 times 1. Now negative of negative 1 is positive 1. So I have positive 1 plus or minus the square root of Negative 1 squared is 1, minus 4 times 1 is 4. 4 times negative 1 is negative 4. Divided by 2 times 1 is 2. This is equal to 1 plus or minus the square root of 1 plus 4 over 2. Is equal to 1 plus or minus the square root of 5 over 2. So u is equal to 1 plus or minus the square root of 5 over 2. Now remember, we set u equal to 3 over 2 to the power of x. So right here we have, this is actually two solutions. We have 1 plus the square root of 5 over 2, and we have 1 minus the square root of 5 over 2. So let's start with 1 plus square root of 5 over 2. So I have 1 plus the square root of 5 over 2 is equal to 3 over 2 to the power of x. So what I'm first going to do is I'm going to take the log of both sides. So I have log 3 over 2 to the power of x is equal to log 1 plus square root of 5 over 2. Now if I have something in the form log a to the power of b, I can move this exponent b to the front of the logarithm. So this would equal b times log a. So now I'm going to move this exponent x to the front of the logarithm. So now I have x times log 3 over 2 is equal to log 1 plus square root of 5 over 2. Now, I actually took, when I said log on both sides, this was to the base of 3 over 2. So if I have x times log base 3 over 2 of 3 over 2, these two will simply cancel out, and this is also base 3 over 2. And I will have x times 1 is equal to log base 3 over 2 of 1 plus the square root of 5 over 2. So now this means that x is equal to log base 3 over 2 of 1 plus square root of 5 over 2. Now, this is the same thing as x is equal to log 1 plus square root of 5 over 2 divided by log 3 over 2. And if I have something in the form log a over b, this is equal to log a minus log b. Meaning log of 1 plus square root of 5 over 2, that's going to equal log 1 plus square root of 5 minus log 2, and log 3 over 2, that's going to equal log 3 minus log 2. Now this is equal to 0.51 minus 0.301 divided by 0.4771 minus 0.307. And if you simplify this, you get x is equal to 1.868. Now we got to take a look at our second equation, which is 1 minus square root of 5 over 2. Now if 3 over 2 to the power of x is equal to 1 minus square root of 5 over 2, well, this is actually not possible because the 1 minus square root of 5, that is going to be a negative number. And you can't take the power of a positive number and make it a negative number. So meaning this has no solution, and our only solution is x equals 1.868. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 8 to the power of x is equal to 80. Now the first thing I'm going to do is I'm going to rewrite 80 as 8 times 10. So we have 8 to the power of x is equal to 8 times 10. Now notice how we have 2 8s on both sides. And what I want to do is I want to move this 8 to our left-hand side. And the only way to do that is to divide both sides by 8. So if I divide both sides by 8, I get 8 to the power of x divided by 8 is equal to, these two cancel out, so I'm simply left with 10. Now this 8 here is the same thing as 8 to the power of 1, right? And now if we have something in the form a to the power of m divided by a to the power of n, this is equal to a to the power of m minus n. So a to the power of x divided by a to the power of 1, we can think of a as 8 here, x as m, and 1 as n. So if we plug this in, we get 8 to the power of x minus 1. This is equal to 10. Now 8 here, this is the same thing as 2 to the power of 3, right? So I'm going to rewrite 8 to the power of x minus 1 as 2 to the power of 3 to the power of x minus 1 is equal to 10. Now if I have something in the form a to the power of m to the power of n, n, this is the same thing as a to the power of m times n. So 2 to the power of 3 to the power of x minus 1, this is the same thing as 2 to the power of 3 times x minus 1 is equal to 10. Now we have to simplify this, so we're going to distribute the 3. So this would be 2 to the power of 3 times x is 3x minus 3 times 1 is 3. Now this is equal to 10. So now we have 2 to the power of 3x minus 3 is equal to 10, and now I'm going to take the log on both sides. So now I have log 2 to the power of 3x minus 3 is equal to log 10. Now, an important property of logarithms is that, let's say we have something in the form log a to the power of b, right? Well, we can actually move our exponent b here to the front of the logarithm. So this would be equal to b times log a. And this is an important property because let's say we have some 2 to the power of x is equal to 5, right? A simple exponential equation. Well, we can just take the log on both sides, so we can move this exponent x to down, because we can't solve this equation if x is an exponent. We want it to be a real term. So that is why this property is so important. So in this case, as you can see, x in this case is an exponent. It's not an actual term. And if we want to find the value of x, we want x to be an actual term. So I'm going to use this property here and move our exponent here, 3x minus 3, to the bottom. So now we will have 3x minus 3 times log 2 is equal to log 10. Now, because we want to find our value for x, we're going to have to isolate it. So we can do that by first dividing both sides by log 2 to move our log 2 to our right-hand side. So then these two cancel out, and I'll be left with 3x minus 3 is equal to log 10 over log 2. Now, the value of log 2, this is equal to 0.301. And log 10, this is the same thing as 1, because any logarithm always has a base of 10. So this is the same thing as log base 10 of 10. And this is essentially asking 10 to the power of x is equal to 10. So what is x? And x is equal to 1, right? So log 10 is equal to 1. So now we have 3x minus 3 is equal to 1 over, now log 2, that is equal to 0.301. So we have 1 over 0.301, sorry. So 3x minus 3 is equal to 1 over 0.301. Now, 1 over 0.301, this is equal to approximately 3.3223. So now we have 3x minus 3 is equal to 3.3223. So I can simply add 3 on both sides. So now I have 3x is equal to 3 plus 3.3223 is equal to 3.223. Now I can divide both sides by 3 because we want to isolate x. These two would cancel out, and I would be left with x is equal to 6.3223 divided by 3 is equal to approximately 2.1074. So x is equal to 2.1074. And now, remember our original equation was a to the power of x is equal to 80. So if I plug in 2.104 into my calculator, so let's a to the power of 2.104, let me plug that into my calculator. So 8 to the power of 2.104, and yep, it is indeed approximately equal to 80. Because it's not the exact value of 80, but it is approximately equal to 80 because they